Okay, so are my presentation visible to you all?
Yes, sir. Yes, yes, it's
Okay,
visible.
okay, okay. So, so the topic of today's the process of innovation, development, and technology readiness level (TRL levels). Uh, so let me end the commercialization of lab technologies and tech transfer. So first of all, I would like to say that being an having much experience in the field of making projects and all that things, mechatronics, robotics, etc. What is the most challenging problem here is that we make projects, but these projects are not up to the level of uh, the shape, their design, or anything else. It's not up to the mark of the market. Okay, so we have to think a lot of we have to think about a lot of things like does people really need this thing? An innovation can be a lot more innovative. Okay, it can the cost is the major factor about it. How many people are going to buy this? So these things are very crucial if we want to sell our product. Okay, building a project is fine, but we have to sell that product in the market to gain some money so that we can build upon that and make our future more secure. If a company is innovative, we want a company to grow also. Okay, so we have to sell our things. So the TRL levels, the technology readiness level, help us to define our product. So what will be the level of that product? So the first ever step is the innovation step. Innovation is the most important step. We have to generate and prioritize ideas, discovery, and create initial propositions about what is the innovation, what is in our mind that is the innovation. Then we have to do somewhat about the analysis. Analysis basically comes in the applied research area. Okay, so applied research means we have to read some research papers, we have to see what things are available in market, what we are thinking in our mind. Our innovation is that innovation is related to that product. So how our innovation is different, so that is the analysis part. Okay, we have to validate market, we have to justify our investment, and write our requirements. So even in this part, the analysis part, it is not that much specific thing, but we have to take care about something. We have to have some general idea about what is available in the market, uh, our innovation, how much it is being used in throughout the world. So that is about the simple analysis part here. Then after analyzing, it is the time to develop our innovation. Okay, so analysis is before the development. So what happens is that student have some innovation and they start developing it. They don't analyze it. So we have to analyze it. So it prevents a lot of hassle before the development. We have to hone our requirements. We have to design solution and deliver and demonstrate our requirements that we have analyzed in the previous step, the analysis part. Okay, so after the development, we have to go to the market. So our product is fit for the market. We have to do some trials also. We have to ask audience. We have to give them some demo products. We have to take their suggestions, and then we have to prepare for the launch. And then the product is launched, and we have to track its performance. Also, we have to fix some issues, and after a lot of after its product life cycle, it is the end of the life. So end of the life of the product. So there are some also intermediate steps between innovation and analysis. We have to investigate further. We have to go to and fro from analysis to innovation, then from innovation to analysis. From analysis to development, there is an intermediate step of the development phase. Okay, so while analyzing, we can develop also. So all these steps are intermingled. It is not like that we have to start the innovation uh, with innovation, we have to analyze, and analyze. During analysis, we have to develop some things also, and we have to build more products to go to the market. Okay, product and business is ready to launch. We have to think about that. uh, so we have to think that do we how much quantity we need for the market. Okay, we have to decide a number. That is a crucial step. We have to decide that we want to build this much quantity of the product, and that is only possible if we have done the market research. And then the in life, we have to develop the next version, or we have to end that product. So that is also important, like iPhone 11, iPhone. So iPhone can never end. We have to develop that version from time to time. Okay, so the company has to decide that whether they want to end that product or they want to give a version to that. Okay, uh, and there is some feedback loop also when we are building things, like we have to see that we have to generate and prioritize idea. uh, we have to go to and fro from building more to innovation, and that's all. Okay, so it is not an easy thing. When we develop a product and we have to sell it in the market, it is a difficult process. And to validate this difficult process, we have to track our innovations in the market also by the time. And TRL level helps us to define. They also helps a lot about from going from innovation phase to the end of the life phase. The TRL levels helps that. So let me just start with the TRL level. What are readiness levels? Technology readiness level. The technology readiness level was actually originated by the Stan Sadin at NASA headquarters in 1974. Basically, they were developing that Jupiter spaceship, uh, and during that time, they have to decide that how much is the uh, basically the phases of the technology. Okay, so we will discuss more about the TRL levels, but TRL levels measure the maturity level of the technology. Okay, so basically what happens is when you develop an idea, that idea is in a prototype stage also, and it's also in the idea remains the same, the technology remains the same, but the design changes. The market, it has the strong foundation of the market analysis also. So the TRL levels goes from 1 to 9 basically. There are 9 TRL levels, and the 9 being the most mature technology. Apart from technology readiness level, I would also like to talk about an important manufacturing readiness levels. So actually, TRL and MRL go hand in hand. They go from side to side, and manufacturing readiness level define the. It was first developed by, suggested by the Department of Defense during the Mantech program of the United States of America. So manufacturing readiness level defines that how much cost efficient is the manufacturing of our product. And there are basically 10 levels of this manufacturing readiness level, and again 10 being the most mature of these. And basically TRL and MRL should go in hand. And apart from that, there is the third category of readiness level, which I would like to talk about. It is the investment readiness level. So what happens is that uh, the technology and manufacturing, these are all related to the innovative products. But the startup ideas are not basically, sometimes the startup ideas are not related to a technology also. We don't require a patent for that. So during that, the investment readiness level is a more generalized form. And again, it was developed by the Steve Blank, and it is related to the startups as TRL is related to the technologies. So we have a business plan. How much efficient is that business plan? Are we able to generate money out of that business plan? These are all related to the investment readiness level, and it is more generalized. It is more preferred by the industries. So the higher the investment readiness level, the higher will be the chances to get the funding from the government or from the private organizations. So these are the three readiness levels here. Today we will talk about the technology readiness level in detail, and a little bit about the manufacturing readiness level also. So technology readiness level. This is a brief table, basically clustering called what is the technology readiness level. On the left side, you can see there is a level, and level means that where this technology readiness level can be applied. It can be applied to the science and engineering. It can be applied to software side. It can be applied to the medical science also. And these are the three levels where it is applied. In the science and engineering, the TRL level 1 means the basic idea. What is the idea in our mind? The TRL level 2 means the concept developed. Okay, we have to do the analysis part, somewhat analysis part, and we have to develop that concept. We have to have a strong foundation about that concept. And it is still in the concept phase. It is not yet developed, but TRL level 2 basically clears all our analysis part. TRL level 3 gives the proof of concept. And in proof of concepts, there can be some simulations and a little bit of experimentation, basically tinkering with the objects and components. And TRL level 4 defines the lab demonstration. For the first time, we have made a prototype of a product, and we have done a lab demonstration of that product. So that comes in the TRL level 4. And we will discuss all these TRL levels in detail in future slides. TRL level 5 defines the lab scale validation. Basically, the difference between TRL level 4 and TRL level 5 is that in TRL level 5, uh, basically the conditions are more generalized. Okay, in TRL level 4, for the first time, we are doing the lab demonstration, and in 5, the conditions are much more generalized. We are trying to simulate the things in the actual environment, but that is still in the lab phase. And TRL level 6 defines the prototype demonstration in the actual world. For the first time, we are using that prototype in the actual environment outside the lab. And TRL level 7 defines the capability validated on economic run. So now we have to think product is almost developed. Okay, so, the major design portion is done in the during the TRL level 6 portion. So we have to validate. We have to think about other things now. How much is the manufacturing cost? Will it be useful? Will it be economical? And we have to do some pilot studies. We have to demonstrate it to people. So what are their suggestions on the design? So that all comes in the TRL level 7. We have filtered our design. We have created all the modifications as suggested by people, and then the product moves to the TRL level 8 part. Okay, so the capability is validated over a range of parts, and system is almost incorporated in the commercial design. And at TRL level 9, what happens is that all the things like manufacturing and the economic run, these all studies are done vigorously, and we come to the phase of the TRL level 9, where we can ship our parts in any amount and in any part of the world, and there is no such problem with that parts. And again, it's not like that we have achieved TRL level 9, that we can't we have done all the things. Okay, we have to backtrack our progress also. Again, at TRL level 9, people will give suggestions. We have to make different versions of our product. But what happens is that our technology is validated, our market is analyzed fully, and we know that in spite of all that design changes, in spite of all that suggestions by the people, we have a strong foundation that we will earn this amount of profit from a product, no matter how many design changes are there. The system is proven and ready for full deployment throughout the world. So in the software side also, we can say the similar things. Uh, it is almost similar. As you can see in the software side, the TRL 11, 1 and 2 are not basically that much applied, but in the directly we reach to the TRL level 3 side. And the TRL level 1, 2, 3 are related to the basic research type. From 4, 5, 6, 7, we go from the lab phase to the actual environment phase. And tier 11, 8 and 9 are related to the regions where our product is fully deployed in the market. So in the medical science, as you can see, it's not that difficult. There are, in medical science, as you can see, there are some trials, basically phase 1 trial, phase 2 trial, phase 3 trial, and phase 4 trials. So if you want to apply TRL levels, they can be applied to the phase, these medical phases. And last line, as you can see, there is a phase. And we can basically divide these TRL levels in 3 phases, in 3 broad phases. First is the research phase. As I said, that TRL level 1, 2, and 3 are related to the basic research type. All the things are basically a proof of concept, involves the simulation part, and they can be, these are all just copy material. No such lab work is done in that phase. All the research part is done because we have to have a strong foundation of the research. And 4, 5, 6 and almost 7 are related to the translation from research phase to the development phase. And the technology is fully lab secured. We have tested our technology in the labs, and it is the translation from that copy phase to the actual product phase. And TRL level 8 and 9 are related to the commercialization phase. We have to start thinking about the commercialization in that part. So so Let us discuss about the TRL level 1 basic research. All that copy material on the board, we have to type the formulas, we have to think about, we have to discuss with the team that what we are thinking about the product, is that product is viable, what we are thinking is right or not. We have to talk with people, we have to do some initial research findings, and that is related to the TRL level, tinkering with the formulas and tinkering with the uh, if we even have a lame idea, that is okay, but that is TRL level 1. We have an idea in our mind, and it can be any idea. We have to do some applied research in the second phase of the TRL level, and we have to include some supporting information. If we even if we have to file some patents, and we are thinking about having them granted in future, we have to have some basic research. We have to have some research papers that yes, the technology is uh, actually applied in the actually is useful for the world also. We have to have some market research in this portion. Okay, so most of the work is analytical or paper studies, and with the emphasis of understanding the science better. We have to understand what is the science behind the what we are thinking about, that our product. Okay, so just for example, we are thinking about making a sanitizer machine. Okay, so that comes in the TRL level 1. And we know something in a mind that sanitizer you have a nozzle, and that sanitizer comes out. Okay, when we come to the TRL level 2, we have to find some research paper, we have to find some circuits online, we have to check that uh, what are the basic components required, uh, what is the power consumption in that sanitizer, will it be viable throughout the, or how much maintenance it will require. That all things are we have to analyze in this in the TRL level 2 part. Okay, so that is important before going to the development phase. In the TRL level 3, we have to do some critical function. We have to find the get the proof of concept established. And as you can see in this picture, this is a picture about the proof of concept, representing a proof of concept. Okay, so we know what are the components. We know that it is a Arduino microcontroller and all that. We have okay, we have developed a program. Now it's time to test it. A rough test, or just a proof of concept to say that yes, the things are working. I remember that company called me in Baddi, and they told me that they want to build a machine basically, and which can test that whether a helical gear is right-handed or left-handed. Okay, so based on the direction of the helical gear, we have to test it whether it is right or not. They were saying that it's a manual process, and the person has to stand here and he has to see that the gear is left or right-handed. They want a machine that can test it. So I just prototyped on it breadboard. We have used laser sensor and tested that, and I made that video and sent them that this is the proof of concept. Okay, so I have this gear, and this proof of concept is testing it that it works. The actual machine is much bigger, the actual machine is much standardized, so that is a different concept. But on the breadboard the things are same. The breadboard is doing the same thing as that machine, and it is just checking that helical gear. So that is the validation of that system. Okay, so that is the basically proof of concept. We can do simulations also. Modeling and simulation may be used to complement the physical experiments. That is also validated. We have some. We should have some laboratory test performed. Okay, some SEM analysis and all that. That validate a proof of concept. So that comes in the TRL level 3 part. TRL level 4 is the first time lab testing after developing just a rough prototype. Okay, so from breadboard to some circuits, and just a design to develop system. So on the you can see the picture here. I will show you this video also uh, at the end of the session. Here is a robotic arm basically, and here is a code I have developed, an augmented reality code. That what it does is that whatever gestures are performed using this code in front of the camera, the robotic arm detects it and perform that similar in the physical world, that same action in the physical world. So this is just a laboratory testing. So yes, this robotic arm is not useful for the actual world right now. It can't be used to hold objects. It cannot be used in the long run also. It cannot be used in sunlight also. And because there are a lot of things, the parts are not standardized here in this robotic arm. During this manufacturing of the robotic arm, I know I have to grind and I have to sand a lot of things inside these 3D printed parts. And yes, it is not at all standardized. So that is why it comes in the TRL level 4. We can't say that it's a TRL level 7 or 8. Okay, so that is the most important thing. We misunderstood things. The students basically, before the knowledge of this TRL level, they misunderstood that they build a prototype, they go to the hardware hackathons and they say that we want to sell this in the market. So that is not a thing. That is just a prototype. It is not ready for the real world applications. The prototype is a different thing, and this is just a prototype. But yes, it is validating the proof of concept through the breadboard, and after that, it is validated some basic design in the lab. So in the laboratory environment, it is working fine. And this is the basically TRL level 4 part. So basically, what most of the projects are built by the student, they are at the level of TRL level 4. And this is the basic technological components are integrated to establish that the pieces will work together. So that is the important thing. Okay, so the basic components are all merged together, and we think about that. We see that whether they are working together or not. So that comes in the TRL level 4 part. Okay, so after the what is TRL level 5 then? The laboratory testing of the integrated, semi-integrated system. The key difference between TRL level 4 and 5 is the increase in the fidelity, in the faithfulness of the system to the environment of the actual application. So on the left side, you can see a person without an arm holding an object with this robotic arm. So in TRL level 4, we were not able to do that, even hold an object. Still, the person is sitting in a laboratory. The robotic arm required batteries or maybe electrical power from an outsource outlet, and it is not useful for the actual world. It is only useful for the laboratory phase. But yes, we are step by step building, and we are basically exposing this robotic arm to the actual environment that it has to go ultimately in the market. Okay, so ultimately in the market, it has to do all sorts of things. So in laboratory, we are testing that actual things. So this is the main difference between the 4 and 5. 4 and 5 just demonstrates the process, demonstrates in the lab environment. Basically, the design is also good, but in TRL level 5, we are exposing the robotic arm to an actual system. We have started this exposure. Uh, the system is again in the prototypical state, and scientific risk should be retired at the end of the TRL level 5. So scientific risk means the basic research that should be done. There should be no doubt in the mind of the inventor or a company that there are some loopholes in the scientific principles behind it. So scientific principles are done with it. We have to just now focus on the design aspect and on sending this product to the market. Okay, so in the TRL level 6, prototype system is demonstrated in the operational environment. What we have done that we have made a simpler form of that robotic arm, and basically think about the market. We have started thinking about the economy of that product, and we have uh, taken what was useful from that robotic arm and discarded what was not useful, and sent them to the people for the trial runs. So the major difference between the 5 and 6 is the step up from the laboratory scale to the engineering scale, and determination of the scaling factors that will enable design of the final system. So the scaling factors are determined. The final design, what will be the design of the final system? That things are basically tested here. We have engineered products. We try to standardize the manufacturing of that system. We discard what was not useful. We use what was economical, and we started thinking about the economy here. And the again the major difference between 5 and 6 is that we have taken that system out of the laboratory and given that system to a physical person or someone for some trials, for some pilot studies. So it includes the fabrication of the device on an engineering pilot line, basically. And now, what is the TRL level 7? We are doing some pilot studies. We are doing these continuous changes in the design of the system. The final design is almost virtually complete. Okay, so again, the risk of the all the engineering and all that are already retired in the previous steps. Okay, what we want to focus here is on the design aspect of the system. As you can see here, the two people are have this prosthetic arm, but these arms are still not that much aesthetic. The looks are not that much aesthetics. Again, the functionality is working right. People may say that they want to change some minor changes in here, that yes, thinking this thing is not working, that thing is, if you can change that, they give their suggestion to the company back. And the company, what it does is that okay, we can make that changes, we can do changes in design. So during this phase, the company doesn't have to think about what is the technology behind. Okay, the technology is already have a firm ground from tier level 1 to 3. They have done all the basic research. 4, 5, 6, they have done the laboratory experiments and given some pilot studies. It has the firm basis. Technology is not that problem. The problem is here is the design of the system, and the design is a crucial step, because design defines that whether your product will sell in the market or not. You see, a product can be a very good, but even if the design is not that good, okay, so the same product can give the same results, but if the design is not that much good, the product will not sell in the market. So design is a major key important step, and this is a major problem in most of the academia world. They don't bother about the design portion. So design is important. The design patents are also important. uh, it has that value, it has value there. Okay, so technology patents are important as well as design patents are important. And so the system process prototype demonstration in an open environment is done. And goal of this stage is to retire the engineering and manufacturing risk. All the manufacturing, the part is already standardized. There is no, if you remember that in the TRL level 4, what I TRL level 4, I showed you the robotic arm that I made, and I said that after done a lot of grinding and all that sanding to make that. So that is not a problem here. The parts are already standardized. They are manufactured in a standard way. Even TRL level 7 and TRL level 8, there is no difference. You can sell this product in the market, but the key issue is its design. Okay, so the people may not buy because of its design. Okay, so what happens is that we have improvised our design here, uh, and we are already testing that in the real world environment. And the product performance delta to plan needs to be highlighted to plan the close of the gap, which will need to be developed. So basically, the delta, uh, the technology is not that problem. We are now dealing with the graph. We are now the company is dealing with the plan to launch that product. This product is fully developed here. Okay, all that need is some painting and some basically some minor design needs, and that's all. Okay, so the TRL level, it is a commercial design, basically what this person is holding, and then there is no technology problem in that. Uh, in TRL level 8, we determine the true manufacturing cost, okay, and based on the deltas of the models, and we develop plans to address this manufacturing cost. So the major thing about the manufacturing here, we are thinking in the bigger terms in the TRL level 8. So we have made this robotic arm. Yes, it is already standardized. It has all the validation here. Manufacturing cost is this much of the one robotic arm. But what do we think about the 1,000? What do we think about 1 lakh robotic arms? What will be the cost of these 1 lakh robotic arms? Will the cost be justified? Will the people in which we are selling this robotic arm will be able to buy this? Uh, how much cheaper can we go? Okay, how much inexpensive can we make this robotic arm? uh, can we have some funding? We think about the funding. If we have this much funding, then what will be the outcome in the next 10 years? So these all the things are determined in the TRL level 8 system. And tier level 9, our product is fully deployed. Again, this is not a real product on the left side, and basically a computer model. But if you can think that it's a real product, on the left side it's a robotic arm that is fully deployable. It's available everywhere in the market, maybe in future if it happens. And if any person has some prosthetic problem, just he buys it and he attaches to his arm. And yes, it doesn't matter. There is no such thing like that whether the arm will fit or not, in the whether the person is short or small. It is available in all the sizes. It is available in all the diameters, etc. There is no engineering issue, and all the problems are well taken care of. So that can be a hypothetical concept of the robotic arm, that it is fully deployable for the uh, in the market. Okay, it is common among the people are also buying this product because they are finding it uh, basically the aesthetic look is giving them uh, motivation to buy this product. So all these things are well taken care in the TRL level 9 system. So most of the industries basically focus on the TRL level 8 and 9. They want products, they want startups to go, they don't invest much in the TRL level 4 and 5 system. They say that your product has to be in TRL level 7, 8, 9 in order to have some funding. So let me give you an example of the TRL level. Basically, this is a this is a basically nozzle. This is basically a system developed by the NASA to prevent the sonic booms in the. mm okay, so what happens is that when an aeroplane moves faster than the speed of sound, there is a sonic boom. So they have to prevent that sonic boom to prevent any unwanted damages in the uh, aviation system. Okay, so they developed this technology. So in 1980, the TRL level 1 and 2, what these are an example. They studied the basic theory. They studied the basic fluid mechanics of the system. Uh, okay, so the using the basic concepts, they designed the early nozzles in the TRL level 3 system. They designed different nozzles. They were testing it in the laboratory. And in TRL level 4 and 5, the first prototype was developed. Again, it's a lab prototype and a small scale prototype, basically, 4 and 5. And yes, it was not good for the actual environment. Actual environment means it was not able to hold the loads of the actual load required by an aeroplane. So it was just a small prototype that developed in 1995, 1997. A subscale model was developed, and the acoustics were determined and they were tested. And in TRL level 6, full-scale test was developed. They have a full-scale flight, and they deployed that system in different engines, some small engines, and they tested in TRL level 7. The validation was already done, and the flight tests were performed in different subscale in different systems. Basically, small aeroplanes, they tested their models that whether uh, what will what happens is that they have already tested that yes, the system can prevent sonic boom, but they were just tinkering around. They were just taking that system and attaching it to different size of the jet planes, and they were testing it at what is their performance. So in the TRL level 7, they did that. And TRL level 8 and 9, they fully deployed that system in the aeroplanes and jet planes. And yes, it increased the performance, it increased the uh, uh, it prevented the destruction of the engines while moving faster than speed of sound. So this is the example of the TRL levels developed by NASA. In the space technology and R&D system, if we can summarize what are TRL levels, it is TRL level 1 is just the basic principle, 2 is the application, applied research, as I said, and third is the proof of concept. Okay, so 1, 2, and 3 are basically related to the research and proof of concept, and these are not that much difficult part. The difficult part starts from the 4 TRL level 4 part. We have to validate that system in a laboratory, and in tier level 5 we have to do some verification in the relevant environment. Also, we have to give this the system that we have developed, we have to expose that system to an actual environment again, but that is in the laboratory part also, laboratory part only. But in tier level 6, we deployed that system for the pilot studies. We moved that system for the demonstration in the actual environment. And tier level 7, uh, we have to uh, uh, further improvise in the design of the system. And tier level 8 and 9, we have to tinker with the design of the system. We forget about the technology, we only take care about the design of the system. Okay, so these are the tier levels again. Let me talk about, this is an important slide here. Uh, how TRL levels are, how much funding is given by the government or the private sector on the TRL, based on the TRL levels. It is a relation between the TRL levels and the funding. So as you can see, the government, what government does is that it is able to fund a system from TRL level 1 to 7. Okay, so but in private sector, as you can see, they are not basically uh, most of the private sectors, as you can see, the funding nowadays, and they are not they just want the final system. They are not basically they want they're interested in the 1, 2, 3, 4 TRL levels. They say that just give us the product and we will change the design and we will do the funding here. This is the difference between the government and private sector. The small businesses that are the startups, etc., they deal with the TRL level 3 to 7, 8, 3 to 7. Okay, so the small startups, they don't have that much amount and that much money that they can fully deploy that system throughout the world by changing the design. They can have some pilot studies, they can do marketing. They don't have that much amount, so they just develop prototype. They just change the design a little bit, and these small businesses do tinker with the TRL level 3 to basically 7. And very large businesses like the you can say Microsoft and uh, well, these are the name, but there are many more also. And they basically tinker. They basically want deals with the TRL levels of the 7, 8, and 9 part. Okay, so small startups give their technology to these businesses, and these businesses just tinker with the design. They don't deal with the technology part. Again, their technology part is dealt by these small startups, and the large businesses are mainly dealing with the profit part and how they will deploy that system to the throughout the world by changing the design, and they do some marketing. They have the money for the marketing part, so they are interested in the 7, 8, and 9 part. Okay, so academia part, where does the academia part, like we people, basically the university people, the university faculties and students, where does they lie? And mostly in the academia, the students and faculties deal with the TRL level 1 to 5. Maximum they go to the 5 part, and it's very rare that they move to the 6 part and do some pilot studies. And you can see that most of the times, what we do is that even I, what I do, but I file a patent, I invent something, I file a patent, and then that's it. I don't have the resources, and most of the time we don't have resources to go to the market to do some pilot studies, and that all requires money. So we move to the government sector. We give them their proposals. But again, that is the key point here is that today I want to share is that mm, we have to step forward a little bit. We have to take some effort here. We have to change our state from TRL level 5 to 6. If we can do that, if academia can do this, yes, they can get a lot of funding from private sector and from government. Okay, so we just have to do some pilot studies. We have to gather, we have to focus on this part also, apart from developing the technology. So this is the point I want to this is the key point I want to discuss in this presentation, that we have to move forward a step from TRL level 5 to 6, so we can have some government funding. We have to think about the design aspect and some marketing aspect also, if you want to progress uh, in the startups. And government labs, basically, yes, again, they can fund you to the TRL level 6 part, but again, the government is not that much interested in the deployment of that product. We have to move to the large businesses from uh, to sell our product in the market. So, what are the challenges in TRL? Yes, the universities, as I said, they deal with the TRL level 1, 2, and 3 part. And the main challenges come in the 4, 5, 6, and 7 part. Because 8 and 9 TRL level are dealt with the industry. 1, 2, and 3 can be developed by the students. And the key challenge is for us, the faculties or the entrepreneurs or the startups, little startups, and they have the key challenge from moving from the 4th to the 7th TRL level. Okay, they have to think about the better product. They have to think about the performance and sustainability of the product. They have to deal with the lower cost and deal with the faster production time. Okay, they have to think about the higher return of the investment. And in from 4 to 7, they have to deal with the commercialization. They should know about the marketing and the sales, and they again should have the customer feedback, and that is very much important because that is the key point that will help us to sell our product. And the university, basically most of the universities, and again city university is a good university, and you are fortunate that you have all these facilities, and you spend money on these startups, but most of the universities in India are, they lack the resources, and also the experience also. They don't want to spend that much amount in that. So industry has no time or interest also from 4 to 7 in the development phase. They want just 8 to 9. So these are the key challenges that we academia people and some small startups face, shifting from 4 to 7 TRL level. Okay, so these things are to be dealt with. So again, the technology transfer life cycle, as the presentation was also about the tech transfer. Uh, I would like to talk about a little bit about the technology transfer. But basically, what happens is we do some basic research, and we invent something, we evaluate something, and the first thing what we do is we do the IP protection of that system. We hire some lawyer, and we file some patents, and after the IP protection, we develop the proof of concept. Then we go in the development phase. Okay, so this is the technology transfer, and again, this total technology transfer life cycle is dependent upon the TRL level. So TRL levels and the technology transfer life cycle go hand in hand with this system. Okay, so the product development and public use on the economic growth, these are basically TRL level 8 and 9 part where the industry is involved. The invention, evaluation, and IP production is done by the TRL level 1, 2, and 3, basically basic research and this part. The proof of concept and the marketing, licensing, etc. is the 4, 5, 6 part TRL level. So these levels, TRL levels and technology transfer life cycle is intermingled with each other, and they can't be differentiated separately. So let me give you this. This is the last slide here, and this is an example of the lab scale testing of the Bionic arm that I recently developed. This is a video just to end this presentation here. The code was written in Python, and this Bionic arm is what it does is I developed this code here, and this is a laboratory Bionic arm, and you can see the Bionic arm is all 3D printed. Yes, I have not taken any feedback from the customer, so that is why it is in the TRL fold. It is in the laboratory part, and whatever actions are performed on the screen, all these actions are performed by this robotic arm. It is homemade. It is 3D printed, and just a proof of concept. Beyond the proof of concept, in very controlled environment, I am doing this experiment. So as you can see that when I put my hand forward, the prosthetic hand. So this is an OpenCV code in Python, OpenCV and TensorFlow system. The code is developed in TensorFlow, and what is it is doing? It is detecting the joints of my hands, and whatever actions are performed with the joints, it is calculating the angles and transferring to the serial communication to the processor of the robotic arm. Okay, so this type of projects come in the TRL level 4 part. Okay, so thank you for your kind attention and for listening to this presentation for that much time.